Okay, before moving into how one would output this data, I just want to show you a more sophisticated version of this processing of motion capture in Fabric. So here I have a animation that comes from the BVH animation that comes from the CMU library. So you can just plug this in here directly. So we'll draw just the original animation. Just bigger expose so you can see. So this is the original animation. And originally, so since it's a BVH, there is no mesh. So let's say you want to either change the character proportions or you just want to drive a mesh with it. You could use this Viper Retargeting solver, which is inside Fabric Utils, and all it does is it uses a JSON file with the names of each bones and uses that as reference to retarget motion between different characters. So this would be the result of transferring the CMU motion to the sample character from the Max Planck Institute, and you can see it's actually pretty good, but the foot, his feet actually they slide in the air. So we could then use that foot step detector we used in the last example and do a constraint. This is what we have right here. So here you can see the foot the constraint detector, and then we use a IK solver, which was actually not built by me. It was built by another guy called Eric DeVierge. But since this Fabric engine thing is extensible, we can just plug it in here and use to drive the lag. So if you see the result of that, it would be like this. So now the foot gets frozen whenever it touches the ground. So you can do some pretty sophisticated stuff before you move your data into your final application. Okay, so I'm gonna load an example of how we stored the animation in a JSON file. So here we have basically the same idea. We load a BVH character, and then we draw this character just for the sake of visualizing it, nothing more. We could unplug this and it would still work, but then we can visualize it's working correctly. Here I clone this data because I want to localize the character. If I don't clone it, I would localize all instances of it. So you can see, like, if I do this, let me just make it loop. If I do this right here, you can see it has actually been localized. I'm just not drawing it localized. And then I store this as a track set array. What's a track set array? It's just a track of keyframes. So for example, if I'm going to store a position which has 3 axes, X, Y, and Z, each track would need its own keyframes, keyframes for X, keyframes for Y, and so on. And each bundle of these tracks, like a bundle of positions, actually a bundle of X, Y, and Z would be a track set. And here we have a track set array because we have an array with the animation of all the transforms from the character. So here I'm storing this array. I can store just the orientation, the translation, the scale. Well, in this case, what's useful for me is just the orientation. If I look at this is actually a preset which accumulates in a variable all the previous expos, character expos. So as I run the animation, accumulating in this variable all the positions in the character, all the keyframes. And then finally we get a clip, and a clip is just a group of track sets with a name. So I could give it a name like character, and then we keep accumulating this if it's not the final frame. So here I have a logic, initial frame, start frame, and then final frame. And if it is a final frame, then we save the clip to JSON. Okay, and if it's the starting frame, we clear the clip and start all over again. So basically, if I run this, just look once like this. Could just do max here, so just saves. Okay, now I have the sample file right here, and it has stored all the orientations from all the joints in all the 300 keyframes. Okay, so here's the name of the clip, character, as we just typed over there. If I change the options over here, if I change this to, for example, let's say I want to store also the positions, I do this, run this again, and there you go. Now I also have the positions of all the joints. Okay, so this would be a very basic storing of the character animation. Of course, we can process this before we store the data, but the nice thing is we can actually store some extra data right here. We could add more track sets, so we could like daisy chain this and add more stuff. Okay, so we could do like this. Of course, it's going to give me an error right here if I play, because I don't have anything in here. But that's actually how our final example is made. So if I look at this one, what I have here is the same, pretty much the same thing. I load a BVH character, then I store the basic character orientation, which is just this part right here. I create a clip, and I name it character again. Then I add the track set, which is composed of all the joints in his body. Then I add another track set, which is just that normalized COG velocity, which is self-accumulated in this vec3 track set, which is just another preset. And finally, I get those footstep detectors. I convert that Boolean value to an integer value and store them as scalar values in a store scalar track set. Okay, so I daisy chain this track sets addition, and finally I save this to JSON whenever I get to the final frame. Okay, so this is basically what our final script is doing. I'm going to run it again, and you're going to see this file is going to change once again, and now we have at the end the custom data we have created right here. So finally, what's really interesting is that you can call this from Python. So I'm going to go through how you would do this in a very brief overview. So basically, we import the Fabric engine as a package in Python. Then we call the client right here, store it, and then we run our extensions that we need to run our script in Fabric, which in this case is my extension, Fabric Utils. And this extension called the DFG wrapper. So DFG is this this graph right here. It's called dependency function graph, I guess. And this is what you need to call it from outside. and then I store some properties. Remember, we're gonna have to feed these properties right here. So what is the BVH file? What's the JSON file? What's the current frame? What's the FPS? What's the starting frame? And what's the end frame? We're gonna have to give it all this data and then execute right here. So this is what I do. I get the input directory, output directory, and the actual place where this script is saved, which is this place right here. Then I call this script. I launch this script right here, and then I feed it with the data. So here I set the arguments, the BVH file, the JSON file, the FPS, the timeline, and etc. So one thing to watch out is that in Fabric Engine's own language, KL, it is you need to explicitly declare your variable types. So you need to do this when you're calling KL functions through Python. So like right here, I have to declare the output functions of the functions I call. But basically I would get the same components that I would get right here. So for example, if I want to read a BVH file here, I use a BVH reader. I can call that BVH reader from the Python file, just as you can see right here. So I do this to get the BVH original FPS and convert it to a arbitrary FPS of my choosing. And then I change the timeline property over here, which is actually the current frame. So just right here, it's the current frame. You can see if I change the frame right here, it will change over there. So I do a range on all the frames and then change it and execute. And then after executing all the frames, the save to JSON node will save the file, and then I go to the next file. So if I run this Python script right here, I'm just going to call it like so. Oops, actually I need to do like this, Python, and it's going to run, it's going to load Fabric Engine in here, and once it's done doing that, it's going to start going through all my files and running this script on all of them. So it's starting to read and write some files already. If I just minimize all this, you can see it's outputting all the files right here to my desktop. It's going to go through my whole database, just doing all the pre-processing, actually the post-processing, and saving the data. Okay, so I hope this has been useful. Yeah, thanks for watching.